topic we are going to see representation of trees, how programmatically trees are represented. There are two ways in which you are going to represent your trees. We already know that tree is a data structure which stores data in non-linear format, right? It doesn't store the data sequentially, it stores data hierarchically. So now if that is the way the data is stored, then how are we going to actually implement it? So there are two ways of representation. One is array and second is linked list. Let's start with it. This is our tree. I have already put down a diagrammatic representation of the same. We already have nodes and they are connected together. So let's try to understand how this tree would be programmatically implemented. So in this case, we have our array list, put down the values. Let's try to understand how these values are put into it. So here, whenever I want to put the left child, I'll do 2 plus 1, where p is the index value. And when I want to put the right child, I'll do 2p plus 2, p again the index value. Let's try to understand the very first node, that is root node A. So I'll put A first. Then I'll try to check where will the left child go. So in this case, left child is B. Now I want to check where will this B be placed in the array. Okay, so how will I calculate it? Here, 2 of P. What is P? 0. Which index value you are going to take? Index value of the parent. So 2 of 0 plus 1. That is 2 of 0 is 0 plus 1, that is 1. And also 2 of 0 plus 2, that is 2. So your left child for this particular node will be put at first index and your right child would be put at second index. Okay, 0, 1 and 2. B and C. Now let's try to move to B node now. Check whether B node has child values. Yes, it has child values, that is D and F. So what am I going to do now? I'm again going to calculate the left and right child. Now for B node, the left child is D and the right child is F. I need to check where this D and F will be put. So for that, I'll again use this 2 of P. Now in this case, P is what? B. Where is B? At first. So B of 1. Similarly here 1. When we calculate this, 2 ones are 2 plus 1, that is 3. 2 ones are 2 plus 2, that is 4. So the left child, that is D, will be placed at index 3. And the right child, which is F, will be placed at index 4. Okay. Next we have is what? We move to the right child. Now right child is what? C. C has again two children, left and right. Again, I need to find out left and right child, where to put it into the array. So I'll again do the calculation. Now in this, again the value of P will change. The value of P will be what? The parent node's value. So what is the parent node? C. What is the index value of C? 2. So 2 of 2. 2 2s are 4 plus 1 5. 2 2s are 4 plus 2 6. So the left child will be put at index 5. So G is put at 5. The right child H will be put at index 6. Okay, that is how you complete the tree. So in your array, this is how you're going to put your values. You will have the tree structure. You will declare an array, a blank array, and you would go one node each. Okay, take that first node as a parent node. Check its left and right. Okay, left and right node. For left node, do this 2p plus 1. P is always the index of the parent node. So you will get a value. That value will help us to know where the left child and where the right child should be placed into the array index. Now second way of representation of trees is by using linked list representation. So linked list, we have already seen the structure of linked list. We have nodes, right? Now in this particular tree structure, we can see that one node has two children, right? So here also, when we are trying to use linked list, the type of linked list that we are going to use is doubly. Okay, doubly linked list. So you have next and previous for this. So in your doubly linked list, you have a node. In your node, you have data, you have previous, and you have next. The node, if you remember. Previous and next. And in between, you have the data. Okay, so that type of a structure is what I'll need for me to store this kind of data. Now how it will store it? in between I'll have data. So suppose this is my node. What is the data in this? A. So A will be my data. What will be at the previous? Previous will have the left child address, and what will be at the next? It will have the right child address. Address, this part stores address. Okay, this concept is covered in your linked list. You'll have to revise that concept to understand this. The very first node that you have is A. So I already have a node created. This node is created first. After that, what is there? The value, the data is put here. And then what I'm going to have? In the left side, or the previous part will have the left child. The next part is going to have the right child. Now what right child? Address of it. Okay, so it will have addresses. So it is connecting to again what? A node. Why node? Because even this has child, left and right. So again there is a node created. So every time you work on this data, you will have to create a node structure. Are you getting it? Every time you work on it, and these nodes are connected. So I have put down only the basic function that would be used. The same code will be used for executing the whole program. Okay, so there are two functions that are there that I have written. Based on that, you can improvise and make the next function as well. So the very first function that I have written is create node. Now in create node, what am I trying to do? Whenever I want to insert a node, I will have to create this structure. So that is the structure I have created here. Again, for you to understand this concept, you will have to check the concept of linked list. If that concept is clear, you will clearly or easily understand this. So in order to insert this value or this node, I need this structure created. So for that, I am creating a structure. If you see this, struct node star create value. So create is the name of the function, and there is a value that is passed by the user. After that, struct node star new node malloc size of struct node. Again, this is dynamic memory allocation for a node. After that, new node to data. Now as I know this is the structure created, the data will hold what? The value that is passed. So new node to data is value. New node to previous, or new node to left, and new node to right. In linked list we were using the concept previous and next. In this I have used what? Left and right. Why? Because it becomes easy to understand left child, right child. Linked list you were using the concept previous, next. Here I am using what? Left, right. Left is previous, right is next. So new to left is null, new to right is null. So I have created this node. I have allocated memory dynamically. I have put the value, the data part, and this part I am keeping it null as of now. It stores address, okay, but for now it is null. I am not connecting anything. This is for creation of node. Now the second function that I have written is insert node. Now insert I have written down for left node. We have two nodes. We have left and we have right. I have written down left. Once you understand left, you will be able to write the right function. So let's try to understand this. Insert left node. Now what am I going to do? I need to insert this node into a linked list structure. So what I have written? Struct node insert. Okay, struct node insert left. So this is the function name. In that, what I have taken two things. One is root and one is value. Okay, now root to left. So now this is my root created. I'm trying to insert a child to it or a left node inside it. So root to left would be what? Create value. Now here, when I want to put a value over here, I need to create this structure. Are you getting it? Create structure function I have written. What is the structure doing? It is creating a structure like this. It is putting the value. These part are null. This thing. Now what this function is doing? What? Inserting the nodes. This function does insertion at the left. This function, the other function will be doing insertion at the right. Now once I have created the node, now I need to insert. So I will name this as root. And to its left, I am going to put a value. Root to left is equal to create val. So what create val? Create val is this function which will do what? Create this. And what is data? Value. I'm passing the value. So every time user is going to write this function, struct node insert left, right? There is a root node that is taken or accepted, and then there is value. Root here in this case is going to be parent, and value is the value that has to be inserted in the node. Similarly, for right side, what you will do? You will have struct node insert right. That is the name of the function. You're going to take root. That will help me to understand which node you want to insert the right node. Next, what I'll do? Root to right. Now this is root. It's right, which is null now. There I have to put a node. What is the node? C. Now to put that node, what I'm going to do? Create the node again. So I'll again call the create node. Are you getting it? So these are the functions that we try to perform when we are trying to work on trees using linked list. So basically 3 functions: creation of node, insertion at left node, insertion at right node. Okay, so that is the implementation of trees.